Hey guys, how's it going? So today is a special day because I get to try out QWEN3 locally, and this is the 30 30B model. So basically, it's 30 billion parameters, and it's an A3B. So one of the experts is 3 billion parameters. Um, the latest QWEN model that I tested was the QWQ and the QWEN 2.5 models, which were both pretty good. They did compete pretty well with DeepSeek R1, and I did like QWQ quite a bit for reasoning, although I did feel that it thought too much, so it kept running into loops in thinking, and it just kept going for quite a bit. But I'm going to test pretty much the same prompt that I had on uh, QWQ on this QWEN3 model. And so right now, as you can see, I will be using the unsloth variant of the model, and there are some guides on the unsloth website of how to run it. There's also larger models than what I've downloaded so far. There's a 32B model and a 235B. However, I don't know if I'll be able to run those uh, because I am already using quite a bit of VRAM on the 3090s. So I think the maximum I could run is a 70 billion parameter on 224 gig graphics cards. Um, and I don't know if I really want to try to run a 235 on RAM and VRAM. So maybe in a future video, if I upgrade my computer, I'll be able to do that. Right now, I'm just curious in setting it up. I've already looked up the requirements from Unsloth, and I have LM Studio currently installed, which is pretty simple to install. You go to LM Studio, just download, and you install it. And to get a new model, you go to the discovery page. You will write in QWEN3, and you're greeted with a bunch of options. I like either there's an LM Studio community model, so those work pretty good off the bat. Unsloth is pretty good, and Bartowski is pretty good. So this time I just download the Unsloth, and when you open it up, you do have quite a bit of variance. So it looks like the largest I could run on graphics cards would be the Q6K model, and I could potentially run the Q8 and float 16 models, but that will be pushing it into RAM instead of just VRAM. So right now I'm going to do the one that has the thumbs up, which is the Q4K XL model. And that seems to be a good compromise between performance and just, um, I guess, being sane and not going off the rails. And I'm going to paste it here, and we're just going to click, and we're going to see how it's going to be thinking. Wait, hold on. How long did that take? 1 minute 54 seconds? But it gave me 679. So unfortunately, I'm gonna say that's a failure. That didn't work. So it could be that the quantization kind of reduced the accuracy. So Q4 on a 30B model for this QWEN3 unfortunately didn't pass. Where the QWQ, here's the one that passed. Let's see. the 30B Q6K, it did pass. And surprisingly, the DeepSeek R1 14B also passed. So, all right. So what we're gonna do now? Yeah, I don't even know. So this is the recommended specs. I didn't pass that. I'm gonna ask it to try again. Think step by step. Try again. So I'm gonna add that prompt, and I've realized that with these QW or QWEN models, the prompt actually matters quite a bit. So if this doesn't work, there is one more thing I'm gonna try, and I'm gonna try to use the QWQ preset on this QWEN3 model. I know that the recommendation from Unsloth is this, but if it cannot answer it, I'm gonna try just one more time after this, give it the best possible way. And I feel like there's no point in testing other things if a thinking model that is based on logic cannot pass this kind of like math problem. And I know it's kind of like a silly question. Oh wow, so it did pass. So there you have it. The only thing I would recommend is I'm going to verify that this is actually correct. So here we're gonna go 361 plus 201 plus 54 plus 36 plus 36. 688. It is correct. The thing is, like, what's surprising me is it is thinking pretty fast. Like, it's only taking a minute to solve this, whereas the QWQ was running for like 6 minutes and it was struggling. So this is quite a bit faster, but it only worked after I said things step by step. So I would assume that this is one of the models that is really dependent on your prompt layout as well. So what I'm going to do is I think I'm going to switch out to a QW2Q variant. So I think we'll try QWQ. And I'm just going to open a new chat. So I'm going to copy this. I'm going to copy. And it's not like it remembers the question when you open a new chat. So the context is reset for a new chat. And let's see what happens. So it's going to be interesting if these settings and how they impact the performance, because sometimes you can have faster performance and a quick result, and just because when it goes through the thinking layers, it doesn't try to correct itself as much. But I'm very surprised at the speed because it is pretty fast. For a 30B model, it's not using as much RAM. It's 10 gigs, and the other card is a 9 gigs. So it is split between two cards. But I think it was running like 4037 tokens per second, which is pretty fast if you see the 32 billion parameter models, they run 17 tokens per second. So I am pretty surprised at just the blazing fast speed that this is giving me. So even if this is, yeah, I feel like if this is if this can be tweaked, this is definitely going to be probably better than QWQ. And I'm going to try also a bit of coding. I'm going to ask it very simple prompt just to build, I think, a snake game just on the basic level. And if it can do that, it's probably might be useful for coding, although I'm not sure. These thinking models, they've never really been that good for coding. Even the QWQ ones, they're probably not as good for coding. But based on the speed, I feel like I can get a bigger model and also a larger quantization of this. I even feel like a Q6 or Q8 would be good. I find that if you get a higher Q value, even though, like if a higher quantization, like a Q8, I in my testing, I saw that even though it runs a bit slower, it gets the job done much faster. So it doesn't have to think um, so long to get the answer. So as you can see, on what did it give me? It's unfortunately I don't think that gave me the right answer. 686. Yeah, unfortunately it didn't give me the right answer. So it did not one-shot it, and I'm not gonna try again. So this just means that trying to use the other presets like QWQ and the context might not be worth it. It's probably better just to stick with the original. It did ramble on for quite long. It thought for 3 minutes and 16 seconds, whereas in the other one it was much faster, like a minute. So there is a low reasoning prompt, which just tells you to reason as least as possible and reducing the temperature with no K samples. So that is, I think I'm gonna try one more time just to see what happens. So it looks like the other prompts for QWQ, where it tries to think as much as possible, didn't work very well. So we're now on the low reasoning prompt, just to tell it to speed up, don't reason too much, just give me the answer and see if that affects it. And unfortunately, if that doesn't affect it, or it doesn't get a better result, fast result, or I would say then just sending it to the original prompt that's on the Unsloth website might work the best. Of course, there is lots of tweaking that we can go do in the future. Maybe spectral decoding will work, which I found did work quite a bit. Having like a large model and then having basically spectral decoding is when you have two models running. So like a larger 32 billion parameter and then a 0.5 billion parameter. So whenever it's like a simple question, it will rely on the 0.5 billion parameter to give you like a yes or no or something when the tokens match up. But when it has to think, it really starts to try to use the larger billion parameter model. So we can try that at some point. But right now, I just want to see the format of the chain of thought here to see what kind of thought process uh, the two answers are giving me. And as you can see here, I don't know if they're similar. So the second one with the prompt was not this prompt, the QWQ prompt. It was thinking in words mostly, whereas the first one was trying to think in numbers. And now it looks like it's just trying to go as many numbers as possible. So the issue here is these weights. Whenever it says wait and maybe, this kind of leads to the repetition and what I was seeing in QWQ models. But it did get the right answer, so I'm gonna say that is a pass in 2 minutes. It gave a one-shot correct answer, 478. Oops, sorry. 478 plus 107 plus 54 plus 49, 688. So at 2 minutes, roughly, I think it was like half the time of QWQ when R1 distilled. So there's a double distill that things forever, but it does give you like way more answers. So Llama 4 Scout couldn't get this to work at all. So if you want to see in context, Llama 4 Scout failed this miserably at 5 tokens per second. It didn't get the right answer at all. Gemma 3 couldn't get it. Exone kind of failed for me. I couldn't get it running properly. Mistral 3.1 didn't get this answer correct either. But it's getting in 2 minutes and 27 tokens per second. It's pretty reasonable. I would say a low reasoning prompt works, or even the default. I think prompt works as well. I think as long as you think step by step, that seems to be working well. Now, I do want to try out a larger quantization model. So I think what I'm going to do is I'm going to download one of those and see if that gets a better result. So if we look here, QWEN3, yeah, this is not going to work for me. 235B, I would really need a computer upgrade for that. And 235B looks like a Q2 would work, but only partially on GPU, mostly in RAM. I do not feel like trying that today, but let's try a 32B by Bartowski, and I'm gonna try a Q6, I believe a KL would be good. So you know what? Let's just stick with Onslaught for now. And it's going to be the 32B. I'm going to try as large as possible without going out of context. So the Q6K, we're going to try the XL, and that seems to like it's going to just fit on 2 graphics cards. Of course, if you're downloading like the 14 billion parameter models, or even the lower parameter models, I would recommend getting as large as you can to fit on your graphics cards. So, and unfortunately in this case, I would opt to get the Q6 over Q4, and it does make a difference. Let's try and see what happens with the 32 billion. I don't know if it's going to be fast or not, because I'm not even sure if this is a mixture of experts model. So when we look online on the on the Unsloth webpage, it says that we have a 32B 128K context length. But this might not be dynamic quantization. So there are even different versions inside of Onslaught. So the dynamic, oh wow, I don't even know which one to choose at this point. Okay, so this is QWEN3 128K, and this is the BNB, the 4-bit with the dynamic 4-bit safe tensor. Okay. So I guess the dynamic would be something to pick up if you're trying to get as much performance as possible. And I might pick that up. But for now, we're just going to be testing the normal 32B. I don't think this is 120 context or anything. So by default, we do have thinking on. That's why I didn't have to tell it to think. Whereas some other quantization models or like some other variants, you might have to say think and start them off, and then for them to actually start thinking. So this does happen sometimes, but it looks like because this is like an official release, we don't have to do that. We can actually turn off the thinking model as well, and I'm assuming that the performance would speed up because we don't have that thinking aspect, but the problem solving skills would go down. All right, so I'll be back once this is downloaded. All right, so it just finished downloading. So what we're gonna do is we're going to eject the current model. You'll see it go out of RAM, and we're gonna load the 32 billion parameter model. So I'm gonna load it with all defaults, and I think I'm just gonna copy this prompt, make a new chat, and we're going to keep everything as recommended with the default prompt. So let's just copy and paste here, and here we go. So it looks like it is using quite a bit more VRAM than the prior model, and this might be because it doesn't have a mixture of experts. You can also see it is generating slower than the 30B variant. It could be that this gets us something that we don't want as a result. All right, I'm gonna have it run, and then once it's done, we'll analyze the results. Wow, and we're back. So, as you can see, it did fail as well. It gave us 686, which is not what we want. We want 688. But the staggering, let's compare. The staggering comparison is it was running at 17 tokens per second. It used 5,000 tokens, and it thought for almost 5 minutes. So, unfortunately, this is probably worse than the QWEN3 variant, which is also 32 billion parameters. But that one did get the right answer. So, I don't know, we might have to play with the prompts, tell it to, think step by step, etc. But on a default, I would have expected this to be much better than it is. And I also want to point out is my RAM is now using almost 50 gigabytes of RAM. On top of that, we're using 16 and 14 gigs of VRAM. So this model is very hungry. Not only that, the context length is 4096, which can be increased, but you will use even more RAM for that. So I don't see a use for this model, unfortunately, currently. I do like the 30B model, so I did go ahead and try to download a larger quant of it and a Q6 quant of the 30B model, and we're gonna go ahead and ask it one more time and see if it can solve it. And then I also want to ask it a snake game, see if it can code at all. Okay, I'm gonna pause here, and I'll be back right after the next one is loaded. All right, so it looks like we're ready to go. This is the Q6 variant. So just so you're aware, this is the Q6 variant of the same 30p model, and we're gonna go ahead and see if it can solve it in one shot. And I know that these tests only apply to kind of like a one side of the brain, because this is like logic and math related. So it could be good at this and then like horrible at everything else. But just based on how many models fail this, even like large ones like DeepSeek R1, and actually like some of the ChatGPT also fails this. I think ChatGPT tries to call a function just to get this solved. And so I'm very curious at this problem and just testing the local models and see which ones can get it. And sometimes I'm kind of surprised based on the responses. Like I would have never guessed that a DeepSeek R1 14B could be better than like a QWEN3. And I think it matters a lot as well if it's like a llama based distill or a QWEN based distill, where I've seen the QWEN based distills haven't been as stable as the llama based distills. So just looking at our RAM, we're at 40 gigs, 14 and 12. It is lower than the 32 billion parameter. And I do see that it is running much faster. Which is, I guess, pretty good. And I think it got it in one shot, so way to go. Okay. 478 plus 106 plus 54 plus 49, 688. Yes, congratulations at 35 tokens per second, only using 4,400 tokens. Thinking for 2 minutes. So this is quite a good result. I think this will be the model that I'll be using going forward. And I probably will never use the 32 billion UD model. So I'm just going to go ahead and uninstall it right now because there's really no need for it. And I'm going to uninstall the Q4 variant because there is now no more need for it because the Q6 runs so fast. So I think what might be worthwhile is actually seeing if this spectral decoding works as well. And what I'm going to do is I'm going to try to find like a small version of this. So it looks like there's a 8 billion parameter, there's a 4 billion, 1.5 billion. All right, so let's say I try to get this one. I just want to see if this will work with spectral decoding. I know it's from Bartowski and not on Sloth, so I'm also going to try and get this one, which is on Sloth 0.6b, and to see if it's even compatible internally. So it looks like the 1.7b is almost ready, so I'm just gonna, it's gonna finish there. And I can select a draft model. So that is quite surprising that I can use an MOE with a non-MOE for that purpose. That's kind of interesting, but I cannot select the other one. So that is also interesting. I can only select the 1.7b, but I cannot select the 0.6 on Sloth. Okay, so what we're gonna do is we're gonna head and turn that on. And I know we're probably getting tired of this question, but I do want to just compare one question exactly the same across multiple models. And as you can see, spectral decoding goes right ahead and highlights it in green. And that's basically telling us that the 1.7b model, which words, which tokens it is analyzing. So I want to see if this is going to be faster or not, and how many tokens per second we can do. I'm also probably going to do like hello world or something, say hello and see if it does full spectral decode. And spectral decode is basically the prediction of, like, if the small model can predict the bigger one, then it could be faster at outputting the tokens. And it doesn't always work. And there potentially is a lot of optimization that has to be done for it. So, like, how much probability you want to cut it off at, and, you know, the max draft size, because at some point you might be losing accuracy. It might be relying too much on the small model and not giving you the correct answer. But as you can see there, it did spit out quite a A lot of chain of thought there. And I want to see if we can get under 2 minutes. And if we can, I think that would be a win. And then we go ahead and run a snake game with this. And if it is not what I'm going to do, I think I'm going to just disable it for the snake game, because I don't know if it will actually work. Again, in the past, these chain of thought models did not code well. So like QWQ is very poor at coding. It's great at math, great at structuring responses, but it fails miserably at trying to code something. And one of the reasons is also because it is a quantized version. Okay, so here it did it. 20 tokens per second. That is quite interesting. It did use less tokens. We are at 65% accuracy, 20 tokens per second, which is quite a bit less than what we had before. We had 35 tokens per second. So it looks like that really just slowed us down instead of speeding us up. So unfortunately, I don't think I'll be using this 1.7b currently. So we're not going to do that. Create a snake game in Python with no external then see, what if we just misspell it? Do you think he'll be able to understand that? Okay, we're just gonna, I guess that's a test on of its own. See, I was trying to go with curses even though I said no external dependencies. Which is, yeah, unfortunate. I probably should have spelled dependency correctly. Might have not known what that is. All right, so I think this is still a thought bubble. Yeah. So this is a thought bubble. So for now, it looks like it is coding in the thought bubble, and then it's going to stop thinking and then output the code. So here it's saying that it's not available by default. Okay, so it did understand no external libraries. That's pretty good. But it still uses curses. Okay. Yeah, so it still tries to import curses and random. It's unfortunate. Okay, so that's interesting. It does have emojis, which is also interesting. I think I forgot to disable visualization. Okay, that makes more sense. So now I'm gonna just try to copy this. We're gonna open up Visual Studio here. So we're gonna open up Visual Studio. We're gonna paste that in. All I'm gonna do is click run. And Right, so we don't have curses, and that's why I asked it to not do that, but did it explain to me that I can install it? Let me just see. No, it did not. So that was also a fail. So it says you will save it as a snake game. Ah, it does actually say it. Okay, perfect. So we're gonna create an environment. I probably should have asked it to do it in JavaScript or something. Okay, so we've installed that. Install. Oh wait, what? Oh, that's interesting. Oh, I can't get it. Come on. You're joking. There we go. Okay, that is a very interesting. And then if I collide, it just ends it. That is actually quite interesting. I didn't expect that to work so well. Now I'm just curious, can we do something else? Can we ask it to do snake game in Java? Do the same using Java CSS in one file, all in one file. So let's actually try to see if it can do CSS. Hopefully it's not going to ask me to get external information for this. I'm not going to get PNGs or anything for it. All right, so here we go. And the way I'm going to do this is I'm actually going to just run it externally. So what we can do now is actually go here, HTML, editor. I'm going to control paste that. All right, so what are the instruction here? Let me see. So it says copy the code into a text editor, name it snake.html, or any name with the HTML extension. So I'm going to do that. And unfortunately, when I do that and open it, it doesn't work. And it just says game over right away and I lose. It couldn't one-shot it. So that is unfortunate. I can actually just get it to try to fix it one time. But other than that, I think this is a failure. Game over instantly. And let's see what the console says. You know what? I'm not going to try to debug it. That it's probably gonna take too long since it's not built the correct way. Let's just see if it can debug itself. Just for context, other models can't do this in one shot locally. They're usually coding models. That's why I said these thinking models aren't necessarily that good at coding. So even though it can have a high score in the coding arenas or benchmarks, it kind of fails kind of instantly, unfortunately. So asking it to rewrite the code, I do see that it tries to do some other thought process here. But again, this thought process is not necessarily what it is thinking about. So based on the new studies and research, this thought bubbles kind of just occur, but it might not be the way that the actual model is thinking. It's just for us to see. Okay, so I'm gonna go ahead and copy that, and I'm just gonna go and edit the code. I'm going to select everything, Control V that, save it, and then I will open it with Edge. So it does seem to be working. Okay, so it is working, it is growing. Okay. There is a score button. Okay, let's see what happens if we hit the edge. Okay, game over. It doesn't restart the game, but we can just refresh it. Okay, game over. So I don't know if you want to call this a failure, really. It did make a working snake game. I know it's one of the easiest ones to make, but it did not one-shot it. It struggled a bit, and I think maybe tinkering a bit with the settings and prompting it better might help, where because it doesn't think as much in these cases, like 15 seconds, maybe prompting it for the larger thought processes and maybe structured responses when it's trying to write a code could lead to better results. So you know what? I wouldn't say this is a complete failure. And I do want to see others use the larger models instead of just the 30B model. The 200B is looking pretty interesting, especially with the speed, like the speed of the response, 35 tokens per second. I assume we can get this a bit faster if we get the um, correct settings dialed in, but maybe coding will require non-thinking. But again, I think that is all for today's video. I don't wanna. This is already taking so much time, and I think it's just meant to be more of a exploration of the new QWEN3 model, kind of long format. I'm trying to figure out as you are seeing this as well and giving some input. It's not necessarily a long response, but I do see some potential, especially because the speed of the response is quite interesting. The the format is there and it can solve quite harder problems where QWQ struggled. So I think this is actually a win, and I do want to see what R1 comes out with, and maybe some other videos if I can find in the chat GPT models that are open source and test those as well. All right, guys, thanks for watching. Hope you enjoyed, and let's see what we can find next time. I'm always excited about the speed at which we're moving through towards the future. All right, thanks, guys.